Good afternoon, and welcome to the virtual book presentation of Margit Olle. Today, Margit is presenting 12 research monographs and 2 popular scientific books, all written in English. And at the end of the presentation, you will also have a chance to win some of the signed books of your own choosing. Margit Olle finished high school with a silver medal and then went on to study for her bachelor's degree at the Estonian Agricultural University, which she finished cum laude. She has also attended the Agricultural University of Norway, and there she defended her Doctor of Science degree on her birthday in 1999. Right after getting the degree, Margit worked as a senior researcher on a postdoc project revealing 2 major discoveries about calcium deficiency in leafy vegetable crops. For 12 years, she worked as senior researcher at the Estonian Crop Research Institute in Jõgeva, Estonia. This working relationship ended with 3 major innovations. And don't worry, we will cover all these 3 topics as well. And since 2021, Margit is leading a non-profit organization called Cultivation. Margit has 8 international recognitions and awards, and she has written over 110 research articles. Being so active in her field, it comes as no surprise that Margit is the review editor of an international scientific journal called Frontiers in Horticulture, and a chief editor of another international scientific journal called Eureka, Life Sciences. And of course, Margit is also a vice president of the International Scientific Center of Fertilizers. Before we get to know the books presented today, let's take a couple of minutes to get to know the first of the 3 major discoveries Margit has made during her career. This one is about negative diff. And after that, we will hear some music from local talent, Mihkel Sildoja, who will play us some traditional tunes.
Today I'm talking about the best methods against dip burn in greenhouse-grown leafy crops. The problem, physiological calcium deficiency, is usually related to the inability of the plant to translocate adequate calcium to the affected plant part rather than insufficient calcium levels in soil. It is a major limitation of the production. The unpredictability makes the problem very serious, and losses can reach up to 50% of the production. Dip burn is usually characterized by the necrosis of the leaf tips of lettuce and by dieback of the young leaves of the chervil. Calcium importance. Calcium is bound in the cell walls. Therefore, when calcium content increases, then the dip burn symptoms are decreasing on plants. Plants are stronger against pests and diseases. Calcium moves through the plant with water flow of transpiration, and once deposited, it's not mobile in the plant. Treatments. Negative diff when night temperature is higher than day temperature, and positive diff when day temperature is higher than night temperature. The number of dip burn leaves per plant of chervil was 78% less in negative diff conditions than in positive diff conditions. Calcium content in young leaves was 24% higher in negative diff conditions than in positive diff conditions. Negative diff decreases dip burn symptoms on plants and increases calcium contents in plants. Positive diff increases dip burn symptoms on plants and decreases calcium content in plants. Take-home message. In negative diff conditions, dip burn is decreasing and the need to use chemicals to prevent diseases and pests is reduced or totally absent. This method is replicable around the globe and can be used in organic agriculture and in vertical farming. It helps to conserve the energy because temperature is higher at night time, which period is shorter. Thank you for your attention and let's eat healthy vegetables.
And now we get to the main part of today's event. Let's find out what are these 14 books Margit has written and what is there so special about them. And let's start with the first one, which is called Best Practices Against Calcium Deficiency in Greenhouse Plant Production. Margit, what can you tell us about this one?
This book involves two of my major discoveries about calcium deficiency. And the first one is that in negative diff conditions, the calcium deficiency disappears on plants. And what is negative diff conditions? This is when night temperature is higher than day temperature. And this second discovery is about far red filter, how to grow plants under far red filter, which filters out much of far red light. And these conditions under this negative far red filter, plants contain more calcium and there are fewer calcium deficiency symptoms on plants. Together with that, one of good practices what you can use is larger root volume. It means that you can grow plants in larger pots, so you can have this NFT larger cubes of, or you can grow plants in larger cubes. And also moderate electrical conductivity, and also spraying with calcium solutions can decrease calcium deficiency symptoms on plants.
Thank you. The second book is called Best Practices in Greenhouse Plant Production. Tell us about this one, please.
Yes, this book involves many practices which can all be used in greenhouses. I told already about two of them. This involves also those two discoveries like negative diff and far red filter, but it also involves one very good product what you can use in greenhouse plant production. This is effective microorganisms, and this technology helps plants grow better, and the quality of plants is much better, especially transplants of vegetable crops. And bokashi tea is also a product which involves effective microorganisms and can also improve vegetable transplant growth. And also silicic acid, which is a good biostimulant, can improve plant growth in greenhouses, and add vermicompost to growth substrate can improve plant growth.
Thank you. The third book is called Best Effective Microorganisms Practices in Greenhouse Plant Production. Please tell us about this one.
Yes, this book involves EM technology and how to and bokashi technology, and I have used EM technology and bokashi technology on several crops. And you can read here how EM technology and bokashi technology can improve the growth, yield, quality, and protection of greenhouse crops. And these practices went into farmers' hands, and some of them are using them.
Thank you. Book number 4 of 14 is called Innovative Technologies for Sustainable Crop Production. Please tell us something about this one.
Yes, this book involves 4 literature overview articles, and those are technologies can be used on open land and in greenhouses. And those technologies are bokashi technology, EM technology, silicic acid spraying on plants, silicon technology, and also using vermicompost in plant substrates, which all improve plant growth, yield, and quality of vegetable production.
And book number 5 is called Vermicompost in Boosting Greenhouse Vegetable Production. Please tell us something about this one.
This book, first of all, involves one literature overview article, how this vermicompost is useful for plant growth and what it does in soil and etc. And also I have experiments with many plants in greenhouses, which all show that the growth and yield and quality of plants are better.
Thank you. And now let's take a small break and see another brief overview about the discovery Margit has made. And this one is about far red filters.
Hello. The title of my lecture is Far Red Filter Reduces Dependency on Lettuce. Far red filter normally is removing big part of far red light which reaches the plant. Aims to show that far red filter could be used to control the height of lettuce plants, to assess the effect of far red filter on the growth and chemical composition of lettuce plants. Treatments. Half of the plants were grown under far red absorbing film, whereas other half of the plants were grown on an open greenhouse bench. Illumination was the same at plant level for both groups. The weight was not statistically different, while the number of leaves which were having calcium deficiency symptoms was much less in far red filter treatment compared to control treatment, and the number of fresh leaves was increased in far red filter treatment compared to control treatment. The content of calcium in young leaves was much higher in far red filter treatment compared to control treatment. The content of chlorophyll was less in far red filter treatment compared to control treatment. Here you can see on the left plants grown on the open greenhouse bench, on the right plants grown under far red filter. Here you can see left lettuce plants grown on the open greenhouse bench and right lettuce plants grown under far red filter. Conclusions. The present investigation shows that lettuce is a crop which responds to change in red-far red ratio. The incidence of deepen injury on leaves reduced under far red absorbing film. The calcium content of lettuce young leaves was higher under far red filter. Thank you very much for your attention.
Cultivation in Northern Hemisphere. Please tell us something about this one.
This book involves articles from Eurolegume project, and Eurolegume project is one European Union 7th framework program project, and those trials have been carried through in Estonia. And this successful legume cultivation project Eurolegume had several treatments, and those treatments influenced growth, yield, protein content, and nutrient content of legume crops in Estonia. And this book involves one discovery. Higher sowing rate can be a crucial component for certain field pea varieties in improving their yield, quality, protein yield. And Jakob Lindam from Aru Agricultural Ltd said that smaller seeds in higher sowing rates gives higher protein content. And if you get a higher yield and you get also smaller seeds which contain more protein, you get altogether more protein yield, which is very good sign. And farmers are very grateful for that.
Thank you. Book number 7 is called Silicon as a Challenge for Sustainable Vegetable Crop Production.
Yes, this book, first of all, I would like to thank Rexil Agro BV and Henk Martin Laane, which introduced me silicic acid, and then I took it into our research, and I was seeing first of all how this silicon acid influences vegetable transplants, which nobody in as far as I know in the world have not seen before, researched before. And I found out that silicic acid improves vegetable transplant quality. And Rainer Soosaar from Kõlleste Garlic Ltd has tried it out on garlic and got higher yield with silicic acid.
Thank you. Book number 8 is physically a smaller one and called Biogas Digestate Bokashi Technology. Please tell us something about this one.
The book contains chapters about biogas digestate and about bokashi technology, which probably is the best method to avoid problems with digestate to use it in agricultural crop production, an innovative method to mitigate with climate change.
Thank you. The next one, another green book, is called Light and Vegetable Production. Please tell us something about this one.
This book contains several literature review articles and one research article from me. Mainly it shows how different colors of light spectrum are influencing the vegetable yield, growth, and quality. And it involves this discovery article about far red filter.
Thank you. And book number 10 of 14 is called Advances in Tomato Cultivation. Please tell us something about this one.
There are several overview articles, for example, about physiological disorders of tomato and EM effects on tomato. But there are also some research articles about silicon, silicic acid, vermicompost, effective microorganisms, effect on growth of tomato. But I was also given one product from ProFarm. This is UVP 110, which I was seeing in trials, and it gave higher yield and also the fruits were larger using this treatment.
Thank you. And before we get to the final 4 books, let's listen to some more music from Mihkel. And now the final 4 books. And number 11 is called The Best Way to Save Our Planet Earth is EM Technology. An interesting title. What's it about?
Yes, I like very much EM technology because you can improve very many sides of our life. For example, you can use it in ceramic, in cosmetics, in building, and this book actually is about how to save our nature. And now is a time when we can turn planet to a safer and more cleaner place to live. In this book, you will read about EM technology, which is absolutely the best way to save our planet Earth. This is one of the solutions what needs Swedish girl Greta Thunberg.
Next one is called Organic Cultivation of Vegetables and Potatoes. Please tell us something about this one, Margit.
The 5 review papers reveals the influence of organic farming on the growth, development, yield, and storage of greenhouse and field-grown vegetables and potatoes. In review articles can be found the best methodology which can be used in organic farming of vegetables and potatoes in order to manage in best way with weeds, diseases, and pests, and at the same time also be productive in yield and gain better quality.
Thank you. And book number 13 is called Methods to Avoid Calcium Deficiency on Greenhouse Grown Leafy Crops.
This book contains mainly my PhD and postdoc works, and the best methods according to this book against calcium deficiency are spraying leaves with calcium solutions, growing plants under fluorescent lamps compared to high pressure mercury and high pressure sodium lamps. And those 2 discoveries, the far red filter discovery and negative discovery.
Thank you. And the last book presented today by Margit is called Effective Microorganisms Influences Vegetables and Soybeans Production. Please tell us about this one.
This book gives an overview about effective microorganism technology. It has one literature overview article in it, and also several crops have been tried out with effective microorganisms, which improves growth, yield, and quality of them. And soybean germination also have been investigated, and soybean germinates faster with EM treatment.
Thank you. These are all 40 books Margit has written. And now that we have reached the end of the books, let's look at the last of the 3 major discoveries. This one is about EM.
Hello, the title of my lecture is The Influence of EM on the Performance of Tomato Transplants. What is EM? EM is effective microorganism. You can see EM logo on the left hand side and how it is sold in the shops on the right hand side. EM technology was developed at the University of Syracuse in Okinawa, Japan in early 1980s by Professor Teruo Higa. EM consists of safe and human-friendly microorganisms. EM technology for agriculture increases yield and improves the quality of production Organic waste can be converted into fertilizer, soil improvement. Problem: elongated low-quality tomato variety valve transplants. Aims: the purposes of this investigation was to assess the influence of effective microorganisms on the growth of tomato transplants, assess the influence of effective microorganisms on the nutrient content of tomato transplants. Experimental site and time was Estonian Crop Research Institute, winter of 2014, and in greenhouses. Substrate: peat-based mixture fertilized with peat care 11-25-24 magnesium sulfate and mixed with dolomite lime. Treatments: one was EM treatment, treated as follows here, and control treatment, which was treated with water at the same time. Replications and experimental design: randomized block design, plot size 6 plants, 4 replications, experiment repeated twice. Laboratory analysis from nitrogen, phosphorus, potassium, calcium, magnesium. Statistics: ANOVA by Excel 2010, comparison of means by Fisher LSD test. Results: tomato transplants height was lower in EM treatment compared to control treatment. Plants were not elongated in EM treatment. The stem diameter was much larger in EM treatment compared to control treatment. It means that plants get quicker the nutrients to the top of the plants and they can take up more nutrients at the same time. The content of nutrients in tomato transplants, you can see here that the content of nitrogen, phosphorus, potassium, calcium and magnesium was increased in EM treatment compared to control treatment. The photo of tomato transplants, you can see here left hand side EM treated plant and right hand side control plant. Conclusions: EM treatment has followed advantages. Tomato transplants stay compact. Tomato transplants have thicker stems. Tomato transplants contain more nutrients. Thank you very much for your attention.
Funders are Norwegian government scholarship in Norway, who helped with her PhD studies. Ministry of Education and Research in Estonia, who helped with her postdoc project. Estonian Agricultural Register and Information Board, Jaagumäe Agro, and Estonian Crop Research Institute all helped with her EM and silicon projects. Estonian Agricultural Register and Information Board, along with Ussimo and Kobrit Limited, helped with vermicompost project. And I believe you would like to say something more about Kobrit.
Yes, Jaak Tõks from Kobrit Ltd found me and wanted to do some trials with vermicompost, and we had long collaboration in order to find out the best substrate for cucumber, for radish, for tomato, and for some other small crops in greenhouses.
Mm-hmm. Huge thanks goes to Project Eurolegume also. And with training and travel grants, Rexil Agro BV and ProFarm Technologies were also a great help. And Rise AB helped with soybean project. And now let's thank specific people also. I believe that you would also like to say something about Maia Naarits, who I heard has a great role to play in what you are doing today.
Yes, when I was a school pupil, I worked at summertimes at Rabise garden, and she was the head of garden, and she was so inspiringly talking to me how to grow vegetables on open land and in greenhouses. So I fell in love with this speciality, and therefore I'm today here talking about my books and everything. Thank you.
So without Maia Naarits, you wouldn't be here today doing what you're doing.
Yes.
Thank you, Maia Naarits, head of Rabise garden in Estonia. And thanks goes to Ingrid Helvi Williams, who was your English language corrector for the books. Gudmund Palvol was a supervisor for Margit's PhD work.
I would like to add that without his encouraging talks about calcium deficiency and to find the best methods against it, I could be nowhere today. And having a possibility to work on this great professor, I was very lucky one, and also to having my PhD scholarship in Norway, because those hard studies made me possible to do science on an easy way after my studies ended in Norway.
And alongside Gudmund Palvol, also Halvard Vågeröd was your supervisor for your PhD work. Dr. Agu Laisk helped Margit with her postdoc experiments at University of Tartu, and Dr. Aare Selge at the Estonian University of Life Sciences. Tarmo Timmi is an EM project manager at Jaagumäe Agro. Rainer Soosaar is a research partner at Kõlleste Garlic. Jaak Tõks is a vermicompost project manager at Kobrit. Dr. Henk Maarten Laane is a silicon project supporter at Rexil Agro BV. Margus S. introduced Margit to EM.
Yes, this is also a great person to thank, because without him encouraging talks about EM and showing me on the fields how it affects the cereal production, I never thought EM would be good for vegetables too.
And also regarding EM, thank you to Argo Kukk, Aive Jänes from AgriPartner. And special thanks goes to Dr. Eduardo Rosa from Eurolegium, and he was a project coordinator.
Yes, this person also has a very strong science view and helped me a lot with his encouraging science corrector hand, and was a great person alongside.
Dr. Fredrik Fogelberg is a former NJF president and soybean project leader.
Yes, this person he has great knowledge about vegetables, but especially about legumes and soybeans, and we have been discussing a lot about science. And during this soybean project, he organized very many meetings and practices on fields about soybean.
Dr. Evald Schnug is a former CIEC president and an advisor for fertilizing topics.
Yes, and this person is a very good scientist, very good leader, and I was happy one to get to know him when at SciEC meetings, and now I am the SciEC vice president, but he was one encouraging person leading this SciEC long time. Thank you.
There are also co-authors. There's 14 books, and they are Eva Schnug, Eduardo Rosa, Ingrid Helvi Williams, Akvile Virsile, Ina Alsina, Liiga Lepse, Sirje Tamm, Ingrid Bender, Aide Tsahkna, and Terje Tähter. And Marit would also like to give thanks to agronomists who helped maintain her experiments and keep the plants well and alive. And they are Barbara Anna Novakovski, Eve Somelar, Aave Lepik, Ülle Ratassepp, Larissa Sirel, Taavi Piiskoppel, Siiri Margens, and lastly, Ele Malm. Thank you to everyone who helped Margit with her books and career. And thank you to all who have been with us today here. And to send you on your way, let's listen to the last tune once again from Mihkel. Have a great day.